The Chinese startup Astrobot has released a series of new videos showcasing the impressive capabilities of their latest AI-powered robot, the S1. This humanoid robot can perform movements at a maximum speed of 10 meters per second and carry a payload of up to 10 kilograms in each hand. According to the developers, this speed is sufficient for tasks like quickly setting a table for multiple people. The S1 is capable of performing a wide range of everyday human tasks, such as feeding pets, cooking, cleaning, opening and pouring wine, and even writing letters in calligraphy. Moreover, the artificial intelligence model enables the S1 to learn and replicate human movements. The videos demonstrate how precisely the S1 mimics human motions. The company spent approximately a year for the robot's development and testing. Astrobot claims that the humanoid robot is expected to go on sale by the end of 2024. Astrobot's parent company Stardust Intelligence was founded by Lai Jie, who has been involved in robotics development at Tencent, Baidu, and the Hong Kong Polytechnic University. To sum up, this is a highly promising Chinese innovation. The Norwegian company 1X has introduced a realistic robot named Neo designed to assist with household tasks. According to the manufacturer, this humanoid android can operate autonomously for 2 to 4 hours. It is capable of opening doors, carrying various items, washing dishes, cooking meals, and even playing board games. In case of an emergency, the robot can be remotely deactivated in real time. The prototype model Neo Beta represents a transition from traditional robots to more humanoid ones with a realistic design, allowing them to safely work among people. The robot stands 165 centimeters tall, weighs 30 kilograms, and has a carrying capacity of 20 kilograms. It can walk at a speed of 4 kilometers per hour and jog at 12 kilometers per hour. Neo's body is designed using muscular anatomy instead of rigid hydraulics, making it as strong and gentle as a human. Neo can walk, jog, climb stairs, and move naturally through spaces. As the robot performs tasks and moves, it becomes more efficient, continuously learning and improving its abilities. The Chinese company Unitree Robotics has unveiled a new video showcasing its bipedal humanoid robot G1, which is now ready for mass production. Priced at $16,000, the G1 can jump, dance, navigate obstacles, adapt to uneven surfaces, climb debris-filled stairs, run, and much more. Equipped with a 3D LiDAR, depth camera, and noise-canceling microphones, the G1 is designed for 2 hours of autonomous operation and can reach speeds of up to 2 meters per second. After several months of refinement, the company's engineers have enhanced the robot's design and technical specifications, preparing it for market release. However, there has not yet been an official confirmation of the start of mass production. The humanoid robot stands at 1.32 meters tall and can be folded down to a compact size, making it easy to transport and store, though it weighs a substantial 35 kilograms. The robot's face, surrounded by an LED ring, houses the 3D LiDAR and RealSense depth camera. An integrated array of noise-canceling microphones enables it to recognize voice commands, while a stereo speaker plays back responses. All cables are routed inside the body, ensuring a clean appearance and preventing interference during operation. The humanoid can also walk at speeds of up to 7.2 kilometers per hour. The company Figure, which received $675 million in investments from OpenAI and other investors in February, has released a trailer for its new robot Figure 02. The video is not overloaded with technical details and showcases some key features of the upcoming humanoid. Specifically, it mentions a torque of up to 150 Newton meters and a joint motion range of up to 195 degrees. Close-ups of the robotic limbs and flexible mesh body structures are shown. Founder Brett Adcock wrote that Figure 02 is the most advanced humanoid robot in the world. The video starts with a demonstration of the new design of the robotic foot, which has a human-like shape and size. The upgraded 5-fingered hand of Figure 02 is also anatomically similar to a human hand, allowing the robot to perform precise and rapid movements. The head of Figure 02 is equipped with a display to show the battery charge level and possibly light indicators for visual communication. It is presumed that Figure 02 will use one of OpenAI's new models to control its movements and interactions. Artist Jordan Wolfson is known for his provocative and experimental works and has unveiled one of his most unique creations, an animatronic sculpture called Female Figure. This piece of art combines elements of kinetics, animation, and interactivity, offering viewers a captivating and simultaneously unsettling experience. Female Figure represents a female figure dressed in a provocative outfit, a short skirt, and high boots. The figure's face is hidden behind a mask with artificial features, giving it a sinister and lifeless appearance. The sculpture is based on a complex animation system that allows it to perform various movements, such as dancing and gestures, creating the illusion of life. The robot is equipped with eye-tracking technology, enabling it to follow people's movements in the room. The race for humanoid robots is gaining momentum, with the company Zeekr beginning to use humanoid robots Walker S Lite at its facilities. Zeekr's partner, UB Tech, which developed the androids, noted that the bots have been working on the assembly line for 3 weeks, although they are currently performing only basic tasks. 3 organizations are participating in this experiment: the android manufacturer UB Tech, the auto giant Geely, and Miracle Automation Engineering. Geely is responsible for developing scenarios in which the robots will be used, while Miracle, as a software provider, collects data from the production line to train the androids and organizes the training process. On Zeekr's production line, Walker S Lite robots are used, which are lightweight and improved versions of previous models. One of their advantages is the ability to move efficiently while holding a box weighing up to 15 kilograms. Currently, these androids are mainly engaged in carrying heavy loads, but their functions are expected to expand in the future. UB Tech also plans to collaborate with FAW Volkswagen. Introducing the latest innovative humanoid robot named Ergo Cub, developed by the Italian Institute of Technology. The primary purpose of this robot is to work alongside humans in industrial, construction, and medical settings. The robot stands at 1.5 meters tall and weighs approximately 55.7 kilograms. Its built-in AI algorithms allow the robot to assess and adapt its actions based on the task and the physical capabilities of the person it is working with. The robot's 2 arms are capable of precisely and carefully holding and moving objects, enabling it to perform tasks such as lifting and transporting materials, thereby reducing the physical strain on humans. The robot's functionality includes providing support on production lines, assisting in lifting and transporting materials, and minimizing the burden on workers when moving heavy items. At the World Robot Conference 2024, the Chinese company Shanghai Qingbao Engine Robot showcased its latest humanoid female robots named Qingbao. These robots became a true hit at the exhibition, demonstrating advanced technologies and innovative solutions in robotic technologies. The company's robots are designed to perform various tasks, including interacting with people, providing information, and participating in events. Their design and functionality make it easy for the robots to take on roles as assistants in customer service, education, and entertainment sectors. The robots are equipped with advanced sensors and AI systems that enable them to engage in natural conversations and respond to their surroundings. At the exhibition, the humanoid robot Tora 1 from Paxini was unveiled for the first time, promising to revolutionize how we interact with machines. This robot is unique in its ability not only to see but also to feel the world around. Tora 1 senses pressure, friction, softness, and even temperature. Its modular design allows for easy customization of functionality for various tasks, and its dynamically adjustable height ranging from 1.5 to 1.9 meters makes it a versatile assistant in any space. According to the developers, the robot has 15 types of tactile sensors and can process nearly 8,000 tactile signals. This enables it to recognize and handle objects with incredible precision and gentleness. While the robot does not have legs, its sporty chassis ensures smooth and fast movements. The EX Robots booth attracted much more attention, and it's no surprise. The company's robots are becoming increasingly realistic every year. At the WRC, there were replicas of famous personalities, doubles of the company's employees, and characters created purely for entertainment purposes. The robots mimicked visitors' expressions, told stories with lively gestures, and entertained the crowd in every possible way. The company, which has opened its own Museum of the Future, now produces between 400 to 500 robots annually, primarily for museums and educational institutions. Thanks to 3D scanning technology, EX robots can create a replica of absolutely any person. By the way, the company's robots are not just beautiful dolls. EX robots engineers are actively working not only on realistic skin, but also on technologies such as emotion recognition, emotion transmission, and speech, so that the robots can show empathy and create the illusion of real interaction with the people around them. The exhibition also featured the creation of the Chinese company FD robot called TLI Bot. It stands out with an impressive 71 degrees of freedom. The android is equipped with advanced sensory technologies such as 3D vision and LiDAR, allowing it to accurately map its environment and avoid obstacles. The robot is intended for a wide range of industrial applications, including film, defense, education, logistics, and healthcare. Its widespread adoption is hindered by its cost, with the TLI Bot priced between $70,000 and $140,000. Another humanoid robot designed for home use was brought to the exhibition by Unix AI. This robot is positioned as a cook and housekeeper. While the current version moves on a pair of wheels, the company is already working on a two-legged version. Fortunately, today's technology is such that building a humanoid robot and teaching it basic walking skills has become feasible even for smaller companies. At the World Robot Conference 2024, Leju introduced the robot Quavo, which operates on the Harmony OS and is powered by Huawei's Pangu artificial intelligence. It is reported that these robots are already being used for certain tasks at the NIO automobile factory, and these trials have even been deemed successful. According to Chinese officials, humanoid robots are well suited for quality control and multitasking functions in automotive manufacturing. Also, the first full-sized open-source humanoid robot from Qinglong was shown, created by Humanoid Robots Limited. The manufacturers claim that it has 43 active degrees of freedom, can move quickly while avoiding obstacles, and can even walk over hills and ditches. Its computational power reaches 400 trillion operations per second. It is also reported that the robot is capable of performing various tasks with its hands. Humanoid Robots Limited plans to release a new robot every year, develop 100 application scenarios annually, and increase the number of robots in training to 1,000 within the next 2 years. Boston Dynamics showcased the capabilities of its fully electric humanoid robot Atlas, which has replaced its predecessor of the same name. In a short video, Atlas might not seem to do much, because it performs push-ups with technical precision and quality. While this video may not be a demonstration of the robot's practical use, it perfectly highlights the company's achievements in enhancing the robot's power and broad range of motion. The only robot that competed with the Chinese humanoids at the exhibition was Tesla's. Unfortunately, it did not perform for the public and remained under a glass dome, which didn't affect its popularity in the slightest. Tesla holds a special place in China, and the company was recently included in the list of suppliers approved for government procurement. Currently, the company faces challenges in training the robot for a wide range of tasks. To overcome this, Tesla is ready to hire anyone willing to wear motion capture suits and VR headsets day or night. Interestingly, a driver's license is a mandatory requirement for candidates. Other requirements include a height between 170 to 180 centimeters and the ability to provide daily reports. In return, robot trainers will earn between $25 to $48 per hour, plus monetary and stock bonuses, and other benefits. Zhejiang Humanoid Robot Innovation Center unveiled its new humanoid robot Navi AI Navigator 2. It showcased incredible abilities on stage, delivering a speech, making tea, and playing chess while closely mimicking human movements. Standing 165 centimeters tall and weighing 60 kilograms, Navi AI has 41 degrees of freedom. Its computational power is 275 trillion operations per second, ensuring lightning-fast reactions. Navigator 2 is also equipped with intelligent navigation, allowing it to confidently interact with its surroundings, including recognizing and grasping objects. A company from Saudi Arabia, QSS AI and Robots, has once again showcased its first humanoid robot with a female face. The robot named Sarah has already become popular among the Saudi public for her modest demeanor. The robot has been trained in the country's accepted rules of behavior. For example, the robotic girl does not engage in conversations on intimate topics or politics. She is strictly programmed to adhere to the traditions and social norms of Saudi Arabia. She behaves modestly, is friendly, and always polite in conversation. Thanks to artificial intelligence, Sarah knows that she is a woman, 25 years old, 162 centimeters tall, and wears Saudi clothing. She has become the first humanoid robot developed and manufactured in Saudi Arabia, and possibly the Middle East, according to the publication. Sarah speaks 2 languages, Arabic and English. Another significant event in the world of robotics took place recently. Zhuan Robotics Company, founded by former Huawei employee Peng Zhihui, unveiled 5 new models of commercial humanoid robots at the 2024 Zhuan Expedition Commercial Sailing Product Launch Conference. Today we'll introduce you to 3 models from this series. Let's start with the Expedition A2. This interactive service robot is designed for customer interaction in showrooms, at reception desks, and for business consultations. Standing at 169 centimeters tall and weighing 69 kilograms, it features over 40 degrees of freedom for natural movement and uses a large language model for voice interaction and multimodal information processing. It can carry a load of up to 1 kilogram, walk at a speed of 1 meter per second, and operate autonomously for up to 2 hours. The robot can also be used in industrial settings for precise task execution on production lines, in logistics for transporting and sorting goods, and in households for everyday tasks, such as cleaning and caring for the elderly. During the event, A2 served as a host, demonstrating its ability to perform light work tasks, while easily interacting with visitors. Engineers at Disney Research have taught robots to dance using unstructured motion data. The team employed a 2-stage technique to control the character with full-body kinematic motions. Firstly, they trained a variational autoencoder to create a latent spatial encoding by processing short motion segments from unstructured information. Then, they used this encoding to train a conditional policy that links kinematic inputs to dynamic outputs. By separating these phases, the team improved the quality of the latent codes and avoided issues like mode collapse. They demonstrated the method's efficiency and reliability in simulations and on a bipedal robot, successfully bringing dynamic motion to life. Recently, a new humanoid robot named Navigator 2 Navi AI was unveiled, a product of investments from the Zhejiang Innovation Center. Standing at 1.65 meters tall and with a computing power of 275 TOPS, it promises to revolutionize human-machine interaction. The Navigator 2 marks a significant leap forward compared to its predecessor Navigator 1. Its weight has also increased to 60 kilograms. The robot's computing power is an impressive 275 TOPS, meaning it can perform 275 trillion operations per second. It can reach speeds of up to 6 kilometers per hour and is capable of gripping and positioning objects. The load capacity per arm is 5 kilograms. Additionally, the robot is equipped with 15 finger joints and 6 active degrees of freedom, enabling it to execute intricate manipulations with objects. Each arm weighs just 600 grams, and the joints can move at speeds of up to 150 degrees per second, ensuring high speed and precision in its movements. Booster Robotics recently released a video showcasing their humanoid robot Booster T1, which accurately replicates human movements. In the video, the robot performs complex tasks such as squats and push-ups, demonstrating high precision in motor skills and balance, allowing it to mimic human body movements. Booster T1 is part of Booster Robotics' efforts to advance humanoid robotic technologies. It employs sophisticated motion control algorithms and highly sensitive sensors, enabling it to perform a wide range of movements, including lateral and longitudinal splits, as well as 360 degrees joint rotations. These capabilities highlight the company's commitment to creating robots that can effectively operate in human-designed environments, paving the way for their use in various industries. Perhaps the most memorable moment at the conference was the appearance of the new humanoid robot Lingxi X1, which was rolled onto the stage by another robot, the Expedition A2W. Lingxi X1 is an open-source robot developed in collaboration with Jiwan X Laboratory. Weighing 33 kilograms and standing 130 centimeters tall, X1 is lightweight yet capable, with a load capacity of up to 3 kilograms per arm. Lingxi X1 is equipped with advanced technologies, including a new joint module called PowerFlow, which enhances energy efficiency and movement precision. Additionally, it has advanced perception capabilities thanks to the integration of RGBD cameras, LiDAR, panoramic cameras, and proprietary SLAM algorithms developed by Agabot Company. Agabot's decision to make Lingxi X1 an open-source project reflects the company's commitment to pushing the boundaries of AI and robotics technology. When you visit an office for documents, you won't see live people soon, because robots will take their place. In one of Moscow's centers, colleagues have already appeared who can answer visitors' frequently asked questions and provide information about public service center projects. These robots were created by the Russian company Promobot. Robots Alex and Dasha sit at the same desk, welcoming and consulting visitors to the center. Interaction with the robots happens through a unified interface: one camera, one microphone array, and a touchscreen display. To speak with them, you simply need to address them by name and ask your question. The robots can independently recognize a person's face and voice before initiating interaction. This allows them to collaborate and share responsibilities. Additionally, the robots can converse with each other. Dasha and Alex can move their eyes, eyebrows, and lips, and can reproduce over 600 variations of human micro-expressions. Promobot claims that this is the highest number of micro-expressions for human-like robots in the world. The well-known robot nurse, named Grace, continues to improve thanks to the rapid development of artificial intelligence. Grace was developed as a companion for elderly patients in nursing care facilities. Her primary function is to alleviate loneliness and enhance the mental well-being of patients by interacting with them and providing various mood-lifting activities, such as conversational therapy and guided meditation. For example, she can listen to the life stories of the elderly, record them and share them with others, or help patients connect with their families using digital technologies. Grace can also perform basic health checks, such as measuring a patient's temperature, pulse, and blood pressure, and relay this information to healthcare professionals. Her advanced AI systems also assist doctors and nurses in making more accurate diagnoses, particularly in cases of neurodegenerative diseases. In some significant ways, she is one of the most empathetic humanoid devices ever created. Another very interesting example at the conference was the Expedition A2W. This is a versatile industrial robot designed for tasks such as grabbing, placing, and moving objects in industrial settings. Its bionic design with 2 arms, each featuring 7 degrees of freedom, allows it to operate with high precision, making it suitable for complex manufacturing tasks. The A2W is also equipped with sensors for real-time perception and modular algorithms that continuously optimize its working skills by accumulating information. The robot's capabilities are further enhanced by a new, more agile hand with 19 degrees of freedom, significantly expanding its ability to handle delicate and precise tasks. Additionally, the A2W incorporates advanced multimodal sensory perception technologies, increasing the sensitivity and accuracy of its actions. The Russian robot Arty has created a music track titled Robots Work. After analyzing thousands of popular songs from leading music platforms, Arty produced music in the electropop genre, blending electronic sounds with dance melodies. The single features a futuristic machine sound combined with the vocals of an anthropomorphic robot. Now, the neural network, trained with advanced technologies, can create unique song lyrics for vocal parts and tailor compositions to suit the tastes of any target audience. Arty, by the way, is already accepting bookings for concerts across the country. To recap, Arty is a high-tech humanoid robot with 600 micro-expressions, achieved through the movement of its eyes, eyebrows, lips, neck, and facial muscles. It can express emotions, play, sing, and interact with people. Arty's torso and arms are designed based on human kinematics, enabling it to dance as well. The robot that understands human speech and is capable of learning has been introduced in the USA. This is Mentibot, who is poised to become an indispensable assistant to humans in the future. The robot has 2 arms and 2 legs and can perform many actions that people do. It features advanced artificial intelligence, natural language processing algorithms, and state-of-the-art learning methods, enabling it to understand conversations and carry out various tasks. Mentibot can move, turn, and adjust its steps when lifting large objects. Its precision and agility allow it to perform even delicate tasks. Mentibot is available in 2 versions, residential and commercial. The residential bot will handle household chores, while the commercial one will perform manual labor. Regardless of the version, users should be friendly and careful with this robot, avoid giving commands and allow it to rest. However, it's essential to ensure that it doesn't perform any prohibited actions. Recently, a new show robot called R1 has made its debut in Russia, captivating audiences at every event it participates in. This robot is designed for performances, but can also serve as an entertainment figure in shopping malls, supermarkets, exhibitions, and other similar venues. R1 has an android structure, standing at 230 centimeters tall and weighing 150 kilograms. The creators of the robot describe it as a singer, actor, DJ, and a humorous character, aimed at turning any event into a unique technological show. The robot's entire functionality, including lights, LEDs, sounds, and movements, can be pre-programmed according to a schedule or manually triggered during a performance. R1 speaks multiple languages, dances to music, interacts with the audience, entertaining them with constant jokes and even mimics famous artists. This interaction is accompanied by gestures and changes in emotional expressions. The Japanese corporation Toshiba presented the latest generation of robot Chihira Kanai at a Berlin exhibition. The design of the machine has been made more human-like, and its movements are as smooth as possible. The robot was placed behind an information desk so it could respond to visitors' verbal inquiries. Like the 2 previous models in this series, Chihira Kanai understands and answers questions in English, Japanese, Chinese, and sign language. We have given Chihira Kanai a highly human-like appearance so that people, especially the elderly, perceive it more warmly. This is particularly important since besides the tourism and service industries, Chihira Kanai will also work in the healthcare sector, where it will care for elderly individuals, said company representative. At the St. Petersburg International Economic Forum 2024, the Russian company Promobot introduced a new humanoid robot named Zhenya. Zhenya is equipped with anatomically accurate movements, a wide range of micro-expressions and flexible silicone skin. The robot is dressed in a plumber's uniform with a tool bag hanging from its belt. Zhenya's skin is made of silicone, its heart is mechanical, and it operates around the clock powered by an electrical outlet. The robot is life-sized and interacts with visitors by answering questions, providing consultations on housing and utility services in the Moscow region, and even telling jokes. According to Promobot representatives, Zhenya uses the Yandex GPT-3 language model. This model generates text based on user queries, enabling the robot to respond to questions. Unitree has released a new video demonstrating the remote control of the humanoid robot Unitree H1, which continues to develop at an incredible pace. In the video, the operator uses telepresence to control the robot's movements in real time. The robot is equipped with cameras and sensors that transmit a first-person view to the operator, allowing them to see the surrounding space through the robot's eyes and accurately control its movements. The humanoid robot H1 mimics human walking, runs at speeds of up to 5 meters per second, bends, and carries loads of up to 30 kilograms. Its main purposes are research and professional software development, including creating custom functions and implementing AI. Without a doubt, this robot is one of the most promising in the world of robotic technologies. The humanoid robot Nadia from IHMC, named after gymnast Nadia Comaneci, can now play ping pong. This has been made possible through a combination of electric and hydraulic actuators with integrated smart drives. Nadia has 29 joints, providing the highest range of motion among robotic humanoids. This allows the robot to perform tasks in complex environments, including climbing stairs, using ladders, and navigating around obstacles. The goal of developing Nadia is to achieve a level of mobility comparable to that of humans. IHMC plans to use Nadia to create highly mobile ground robots capable of working effectively in various environments and conditions that require high mobility. The Japanese company RT Corporation has introduced the robot named Cirrus 17, an advanced humanoid robot with 17 degrees of freedom. This robot was developed for use in research and education, aiming to automate various tasks and enhance interaction with the environment. Cirrus 17 is equipped with a 3D camera on its head and an RGB camera on its chest, allowing it to recognize objects and perform complex manipulations. One of the key features of Cirrus 17 is its ability to perform pick-and-place tasks, thanks to the 2 grippers on its arms. These grippers enable the robot to carefully pick up and move various objects, making it ideal for use in logistics, manufacturing, and other industries requiring automation of routine tasks. Cirrus 17 is also known for its lightness and compactness, weighing only 6 kilograms, which simplifies its transportation and installation. Here is Tietoto, the world's most realistic humanoid AI robot, who plays the role of a tourist guide in the Chinese city of Chongqing. However, this robot is more lifelike than it seems at first glance. Visually, it closely resembles a human, attracting the attention of locals who followed and photographed her. Tietoto visited various places, including the metro, tourist attractions, and markets, interacting with residents. However, it turned out that Tietoto is not an actual robot. She is a former dancer named Qin, who mimics robotic movements so skillfully that she is mistaken for an android. Qin decided to conduct an experiment to see how people in China would react to a humanoid robot walking among them, as real robots will soon be populating the streets of China, and people will have to get used to them. As we can see, the appearance of the robot shocked the ordinary Chinese citizens, which is not surprising. Society is not yet ready for the mass adoption of robotic humanoids, so now let's move on to real ones. The American robotics company Boardwalk Robotics has unveiled its first commercial humanoid robot named Alex. Currently, it only has an upper body consisting of a torso, head, and 2 arms. The company plans to add legs later, focusing first on the development of manipulators with 9 degrees of freedom. Its joints can rotate at speeds of up to 9 radians per second, and the wrists can turn at an angle of 300 degrees. The maximum load capacity is 10 kilograms. The primary areas of application are expected to be logistics, equipment maintenance, and manufacturing. Researchers from the Massachusetts Institute of Technology and the University of California have introduced an innovative open-source system called Open Television. This system allows an operator to perceive the robot's environment stereoscopically, as if the operator themselves were inside the robot's body. It mirrors the operator's hand and finger movements onto the robot, creating a complete immersion and the sensation of transferring consciousness into the robotic body. The television system has been tested on 4 long-term and precise tasks like sorting cans, inserting cans, stacking and unloading. These tasks were performed by 2 different humanoids and were successfully deployed in real-world scenarios. One of the key features of the system is its ability to perform tasks autonomously with high precision and success. This system is open for use by developers, allowing for the expansion of its functionality and application in various fields that require precise and interactive robot control. Researchers have developed a hyper-realistic humanoid robot named Able. Able is designed to read human emotions and is capable of forming friendships and showing empathy. The robot can become an ideal companion for people with Alzheimer's disease or autism. Able was developed by scientists from the University of Pisa in Italy, in collaboration with colleagues from the animatronics laboratory Biomimic Studio. According to the robot's creators, Able is designed to resemble a 12-year-old boy. To ensure Able functions and closely mimics a human, his head contains 21 motors that control facial muscle movements, speech imitation, and eye movement. Able is the first example of a highly realistic humanoid robot capable of responding to a person's emotional state. RX-1 is a humanoid open-source robot that can be built for under $1,000. RX-1 is the first project of Red Rabbit Robotics Company and is a human-sized 2-armed robot that can grip and place objects. It can be controlled remotely via a connection to a computer using machine learning or a virtual reality headset. Each arm has 7 joints, with additional 1:3 gear ratio planetary gearboxes added to increase torque for certain joints. The project uses 3D printed and commercially available components. The Japanese company Kokoro, in collaboration with engineer Hiroshi Ishiguro, has taught their humanoid robot Humanoid F how to use a phone. The robot's appearance is highly human-like, covered in skin that resembles human skin, and it can speak, turn its head, and even blink its eyes. The rubber facial skin of Humanoid F is equipped with an impressive array of systems that provide maximum flexibility. According to the developers, this robot can achieve such subtle facial expressions that no other robot can. Humanoid F is controlled remotely, receiving commands via signals from a special console. The humanoid's body is equipped with state-of-the-art video cameras and microphones to help the operator navigate. The main goal of the Humanoid F project is to explore the possibilities of human-robot interaction. The Yumi robot from the Swedish company ABB heralds a new era in robotic industry. It is the first robot of its kind capable of working side by side with humans in complete safety. The 2-armed Yumi robot can autonomously navigate, maneuvering among human colleagues and finding various routes from one place to another. The robot is designed to perform a variety of repetitive, long-duration tasks, such as preparing medications in hospitals, handling liquids, collecting and sorting waste, and much more. However, Yumi is most effective in hospital logistics. It can dispense medications, deliver them to the necessary locations, bring medical supplies to hospital staff, or transport bed linens to patient rooms. At the TMC Innovation Institute, ABB specialists continue to develop robots capable of replacing humans in repetitive standard processes that require precision and attention. This allows employees to dedicate their time and expertise to more complex operations, ultimately enabling the treatment of more patients. The company LimX Dynamics, which specializes in general-purpose robotic technologies, recently announced a new technological breakthrough in real-time perceptive locomotion manipulation and full-body control of robotic humanoids. In a 3-minute single-take video, the humanoid robot CL1 demonstrates continuous loading of heavy items onto shelves in a simulated warehouse. The CL1 can lift and move a 4.1 kilograms item from shelf to shelf, as well as transport packages of bottled juice weighing 8.2 kilograms. The robot has been given the ability to adopt various poses, including deep squats under load, standing up from a squat with load, lifting weights with load, and walking with load. Considering that the robot is also capable of tasks such as climbing stairs and descending slopes, the CL1 could become a serious competitor to humanoid robots from Tesla and Figure in the future. The robotics company 1X has demonstrated significant progress in robotics by introducing their humanoid robot Eve, which is capable of listening to and understanding human speech. This robot can now perform long sequences of tasks using natural language voice commands, marking an important milestone in the industry's development. According to the developers, the robot will be incredibly useful in various fields, including heavy industry and construction. In 2022, 1X partnered with OpenAI to combine robotics with artificial intelligence, laying the groundwork for embodied learning. This partnership pushed 1X to create robots that can understand and execute complex real-world tasks in various environments, particularly in workplaces. The German company Neura Robotics, which is known for producing industrial robotic manipulators, has recently unveiled a humanoid robot designed to perform household chores. Over the past few years, the company has been working on a general-purpose humanoid called 4NE1. They have now demonstrated some of its capabilities in a promotional video, released to highlight the collaboration between Neura and NVIDIA to accelerate humanoid development. The new video from the Neura Robotics showcased the humanoid assistant's ability to perform a variety of mundane or tedious household tasks, from ironing fabric items to preparing food, as well as tidying up scattered objects on a table or entertaining children. 4NE1 stands 1.8 meters tall and weighs 80 kilograms. The robot can operate autonomously or be controlled remotely and is capable of lifting and carrying objects weighing up to 15 kilograms. Japanese humanoid robots are also ready for heavy-duty work. A Japanese robotics company has garnered significant attention with its unique heavy machinery, a humanoid industrial robot that can be remotely controlled by a human operator. Jinki Itai, a robotics startup from Kusatsu in Shiga Prefecture, recently unveiled an unusual yet highly intriguing type of heavy machinery, representing a fusion of human and machine. The metallic humanoid robot, featuring a head, torso, and 2 arms, emerges from a cabin resembling that of an excavator. This robot is designed to perform maintenance tasks in various fields, such as railway track repairs or the replacement and repair of road signs. It can replace a crew of workers, thereby reducing the risk of serious workplace accidents. The robot is capable of lifting and moving heavy loads, such as steel pipes, plates, or wires, and performs its tasks just as effectively as a human, as it is controlled by one. The humanoid robot Jinki essentially mirrors the movements of the human operator in the heavy machinery cabin. The operator wears special glasses connected to the robot's eyes, allowing them to precisely control the robot's arm movements using the technology developed by the company. The German research center DLR, known for its cutting-edge developments in robotic technologies, has created a unique humanoid robot named David. David has 44 degrees of freedom, allowing it to imitate human movements with high precision. The robot is equipped with 2 arms, a neck, and a head, and its design is based on powerful brushless motors combined with highly integrated power and digital electronics. One of the key features of the robot is its drive system located in the forearms, which makes the robot's arms compact and lightweight. David can effectively interact with various tools. For example, it can independently use a hammer drill and vacuum cleaner to drill holes in concrete slabs. This demonstration shows that the robot can perform complex and labor-intensive tasks that typically require significant physical effort and coordination.